Hello everyone, today's topic is brain tumor detection and its classification using the artificial intelligence. Generally, every year thousands of people die all over the globe because of the brain tumor disease, and people also die due to the delayed or inaccurate brain tumor diagnosis. So, there is an urgent need of a new automatic system that can automatically detect the brain tumor at its early stage. So, in this session, we are going to create a new model for the detection of the brain tumors. Generally, we will be using the artificial intelligence, especially in artificial intelligence, we will be using the convolution neural network. And here the model is generally designed in the three phase. The first phase is the processing phase, in which the different categories of the brain tumor images are acquired, and then after that these images are pre-processed. For example, we read the images, we resize the image into the fixed dimension like 128 cross 128 cross 1, where 128 cross 128 represents the height and the width of the image, and 1 represents the color channel. Since MRI images are grayscale, therefore its color channel is 1. And for the faster processing, we converted this MRI image to NumPy form and reduced each pixel intensity value in the range 0 to 1 by dividing it with 156, because the maximum possible value of an image pixel is 256. And once this image are pre-processed, then this image are forwarded to the models, that is our convolution neural network. We train our CNN model using this brain tumor images, and once the model is trained, the testing phase begins. In testing phase, we pass the test images to our trained model to validate whether our model has been able to recognize the different category of brain tumor or not. So let's jump to the session. For the experimental purpose, I have downloaded the data set from this website. I will provide the link in the description part, and here are these brain tumor images are here. I have already downloaded it. I will show you. See the brain tumor MRI data sets that I have downloaded, and it contains the two folder, training and testing folder. Folder contains the 4 different category of the brain tumor disease. For example, this folder contains the glioma cancer, and you can see here it contains total 1321 images of the glioma disease, and these are its images glioma. And similarly, there is another folder also in this type of this many glioma disease, and you can see here it has 1339 different category of the images of this kind of disease. And similarly, this is the folder that contains no tumor. These are the clean images that are not contain any brain tumor disease. And similarly, this is the pituitary category of the cancers in the brain part, and these are some of the samples, and they are altogether 1457 samples are there, and we are using these samples to train our model, and we use the images that are present in this testing folder for the test purpose. Now let's come to the coding part. First part is, now before I begin, I would like to say I have already executed this code to make the video short and simple. This code is used to mount your Google Drive with your Google Lab, so that you can access the images or the data sets of the MI from your Google Drive. You can see here I have already saved my images here. This is the data sets inside here. This my images are here. This is the dataset that I have loaded to my Google Drive. So I am using this dataset to train my models and test and validate my models. and this line of the code is used to check whether I am using GPU or not. Here I am using Tesla T4 GPU, so it is showing this GPU here. Next is the data preprocessing stage. In data preprocessing stage, I have specified the folder where my training data sample is located. You can access your sample from here. Brain tumor training, you can click this path, copy path, and you can simply paste here. Next, I use this code to load my images that has the extension of JPG, JPEG, PNG, BMP, and GIF. This type of the extension of the images I am loading for my experimental approach, and altogether there are 5712 images are there. Now next, since this image is very small in size, so I'm going to use the image data generator for increasing my training sample so that I will not face any problems while training the model. Generally, we face the model overfitting problem if the data set are extremely low. So to increase the size of my samples, I am using data generator. I am using the data augmentation technique. I am applying this technique to increase the size of my training samples. And here in this code, the same things, and here this code is used to read the image. I am reading the image from here, image.open. I am converting them to the fixed dimension, that is 128 plus 128. This is height and this is the width of the image. Next I am converting it into the numpy form. Then after that I am appending the image to this list and also appending a label to this labels list so that I can use them to train my model. Next I am applying here the augmented techniques that I have shown you previously. This is the augmentation part that I am performing here, that I have shown. This data augmentation, data gen is my data augmentation technique. I am using this data gen for my data augmentation. Next I am saving all my images and my list and my class and my labels to my Google Drive so that I can load it later on. Now this code is used to read the images, their labels and their class names, and once this code will be executed, this image labels and class name will be saved to my Google Drive. Next this code is used to load the datasets that has been already saved in the form of numpy images, MRI images, MI labels, and this class name has been saved in the numpy form. This code is used to load my datasets. Now after data augmentation, I have 17,000 of images. Previously I have, I think, only 5,000 images were there, but after applying the data augmentation, my number of the training sample has been increased to avoid the underfitting problem. Now I have 17,000 of images, and it contains a different category of brain tumor like glioma, this category, this pituitary, and simple no brain tumor images. Next, I have imported the matplot library for the visualization of my data sets, and this code is used to display the 4 images of each class. For example, I have 4 different classes, so it will be displaying 4 images of each class, and altogether there will be 4 columns will be there, and it will display my images. You can see here 4 classes are there, and it is displaying the 4 columns: first column, second column, third column, and fourth column. And these are the 4 images of each class. This is the glioma category of the cancers that is present in the brain tumor. Similarly, this class is of meningioma cancer, and you can see the images. I am displaying the random images from each class, and 4 images are being displayed of each class, and these are of the no tumor, and this is of the pituitary category of the cancer. And I am using this data sets to train my model, and this code is used to plot my data set in the form of the pie charts. And you can see here I have plotted my data samples. These are the distribution of the data sets that are present. For example, out of 100%, pituitary contains the 25.5% of the total data sets, and this glioma contains total 23.1% of images out of the 100 images, and this is the no tumor image are 27.9% out of 100. And similarly, I'm plotting the bar chart. This code is used to plot the bar chart, and I'm plotting it in the sky blue form. And you can see here, this is also for the visualization. I'm plotting here my different datasets. This is the glioma, and glioma contains, I think, near about 4,000 of the images. Similarly, this meningioma cancer type also contains near about 4,000 of the images, greater than 4,000 images. And simply I am visualizing my datasets here, and this code so depicts that I have 17,000 the images for the training, and they have dimension 120 height, 128 breadth, and here one represents it is a grayscale image. And for RGB image, the value of this channel is always 3, and these are the corresponding labels of these images. Next page is the model building. Here I have designed my CNN model for detecting the brain tumor disease. Here I have created a sequential model. It means every layer are stacked on top of each other, and I have used the 2D CNN here, convolution 2D. It means I am using these layers, and the kernel size is cross tree, the filter size is 32, stride value is 2. It means once the images are forwarded to this layer, the dimension of the images will be reduced by half. If 128 cross 128 image will forwarded to this layer, then the output generated will be 64, 64, this filter size 32, 64 cross 32. And for non linearity learning, I am using this activation function, and I'm setting the padding value equal to same. Then after that I have set the number of the neurons in this layer 128, and after that I am using the dropout to drop the 30% of the neurons here. Next I am using, since I have the 4 category of the brain tumor disease, so I have set the value of the density equal to 4, that is the number of the classes I am going to predict. And since this is a multi-classification problem, so I am using here softmax activation functions. And generally for the binary classification we use sigmoid activation functions, but since this is multi-classification problem, we are trying to take the 4 different category of the classes, so we are using here activation function as softmax. Next, to generate the summary of the model, I am using the model.summary. You can see the summary. After each layer, the dimension of the output image is being reduced by half due to the stride value 2. And you can see here I have also stated value of the stride here 2, here also 2. And finally there are 4 different category of prediction, so I am using the value 4. And the total parameter is 1 lakh near about. I am using all these 1 lakh parameters of my models for the training, and non-trainable parameter means 0 it is. Now for model training, model fusion, we will see later on this model fusion, model training. In the next session I will show you how to perform the model fusing, how to combine the 2 models and predict the outcomes, or how to fuse the data sets, how to perform the early fusion or late fusion. I'll show you this later on. And next is this code is omitted. I have not executed this code. And next part is model training. And for the model training, I have used, for the base training, I have used the optimizer Adam, which generally performs for the most of the tasks. And I have set its learning rate to default, that is 0.001 learning. And I have used this loss functions, pairs categorical cross entropy, and I am displaying my results in the accuracy form. Matrix is set to accuracy, and fit function is used to train the model. And for the training, I am using my training datasets, xtrain, and y train is my level, and batch size go to 32, and validation split is chosen in the ratio 9:1. It means 10 percentage of my out of total training sample, 10 percentage of total training sample will be used for the validations, and 90 percentage of training sample will be used to train my model. And I have trained my model for the 50 posts. You can see here my training of my models. This books that has been executed for the 50 books. At near about 50 books, I am achieving the accuracy 98%. It means my model is extremely good in predicting the different category of the brain tumor visit in the MRI images. And this code is generally used to save the models for the future reference. And next, once the training phase gets completed, testing phase begins. And in testing phase, I will first load my models, and for loading the model that has been saved, I will be using this command load underscore model. And once the model is loaded, I will use the testing images. I have specified here where my testing images are there. This is the path of my testing images. Next, after that, the same procedure similar to the training phase. I have specified for the testing. I will be using this category of the extension PNG, JPG, JPG, GIF. Now I have displayed the total number of the images in this folder. There are 30,000 images for the testing purpose. Now image data generator. This is not, I am not using for this for my testing purpose. So I will just remove this code here, testing part. This data generator. I'm loading here the images, converting it to the numpy form, resizing it into these. Then after that, appending the test images to the images list, and appending the its corresponding labels to the list labels. Now this code is used to load my test images, and it will fetch the images, test images in these images, and labels will be stored in these labels, and class name will be saved in these class names. I have different category of the brain tumor disease: glioma, this one, no tumor, and this one. And here again, similar to the training phase, this part of the code is used to display the images, test images of the different categories. I'm displaying here four images of each class. For example, test images of glioma, and test images of this meningioma disease, and no tumor images. Similarly, pituitary cancer images of the test samples. And this code is used to represent it in the form of the pie chart. Similarly, this code is used to represent my dataset in the bar chart, similar to training. Now here I am passing my images, storing the images to the X test and labels to the Y test. You can see here there are total 1300 images are there, and the dimension of these images are here. They are 128 height, 122 width, and they are grayscale images. And I have passed my X test images to my model for the evaluation. Now you can see here I am achieving the 93% of accuracy during the testing. At the training time I was achieving the 98%, something like that. But during the testing time I am achieving the 93%, which is still good in predicting the brain tumor disease. Now here this is the confusion matrix I have plotted. This is the confusion matrix. This is the predicted level, and this is the true level of my testing sample. And here I have plotted the training test accuracy and validation accuracy of my training model that was training at that time. This is the training accuracy and validation accuracy of my model. Now next is the prediction and visualization, and this code I have used for the prediction of the brain tumor disease. Here I have plotted the results. I have plotted the 20 results total of my 1300. Out of 1300, I am just showing the randomly 20 samples results, because it is not possible to see the all 1300 results here. I am just displaying 20 random samples in the 4 column. You can see here it has been executed. Yeah, this one code is my outcome results. You can see here this image was of no tumor, and my model has successfully detected it as no tumor. Similarly, this image was of pituitary cancer, and my model has accurately detected it as pituitary. Similarly, this was also pituitary cancer, and my model also has detected it as pituitary. You can see here how much accurate my model is detecting the brain tumor. It means the performance of my model in detecting the brain tumor is extremely high. It is predicting very accurately. You can see here this one. This is actually detecting. Actually, this was meningioma, and it is also predicting as meningioma. It was pituitary image, pituitary cancer. It is also detecting it as pituitary cancer. So you can see here how much accuracy we are achieving. Okay, from here, but in case of this image, this was glioma, but we predicted it as meningioma. Here we have not able to recognize it accurately, but still no problem. We have recognized most of the images accurately. So we can say that still the accuracy of our approach is extremely high in detecting the brain tumor disease. So this is how we can create a artificial intelligence model for the detection of the brain tumors, and by using this type of the model we can save the thousands of the life of the people before they die. So this is the quite good model, and see you in next session. Till then, bye bye.